Okay, example 4 gets into the eccentricity of an ellipse. Eccentricity is either c over a or c over b, depending on which axis is major. So if the horizontal axis is major, if you got an ellipse like that, c over a, like that, c over b. And eccentricity, the closer that it is to 0, the closer it is to a circle. The closer it is to 1, the closer it is to a very, like one of those. All right. So the higher the eccentricity, the more it squishes, I guess. The closer to 0, the less it squishes. All right. And that's all eccentricity is. It's just another number, and it gives you a relationship between B and C or A and C, depending on what you're told as far as the positioning of the ellipse. So it's just more information. It's something that might tell us. But since the focal points should be less than the major axis, because focal length, major axis length, this B should always be bigger than C, or A should be bigger than C, depending on what it is. These fractions are always between 0 and 1. All right, so find the equation of an ellipse with foci at 0, -4, and 0, 4. So 0, -4 is a focus, 0, 4 is a focus, and an eccentricity of 2/3. Now, first off, I can see very clearly the foci are positioned vertically again, which means the major axis is going to be a vertical major axis, right? That tells me eccentricity for this one's going to be C over B. So anytime they give you eccentricity, you really focus on which axis is major. They should give you enough information, though. They might tell you the major axis is parallel to the y-axis. They might do something like that. Or if they give you the focal points, that clearly defines that the major axis is vertical. All right. So that's how the eccentricity comes into play. The other thing I can figure out here, again, I've got my standard form, x minus h squared over a squared plus y minus k squared over b squared equals 1. That's what it looks like every time. My goal is to find h and k and a and b. Until I have all that information, I don't have enough information, right? So, first off, what is the center?
0, 0.
Very good. Center is halfway between the focal points, which would be right here at 0, 0. Okay, just using basic midpoint formula technique. Halfway between. And that tells me, therefore, the focal length here is 4. So I know that h is equal to 0, k is equal to 0, and c equals 4. Notice I don't have either a or b at this point. Okay? So this is where the eccentricity comes into play. Eccentricity is a relationship between the focal length, which we do know, and b, which we don't know, and the eccentricity is equal to 2/3. So if I take that fact, put 2/3 in place of e, and 4 in place of c, that's how eccentricity usually comes into play. You create this little proportion. You're going to figure out what c is equal to or what b is equal to. That can determine the other thing. All right? Cross multiply 2b is equal to 12, so therefore b would equal 6. And we're at the same point where we're kind of last problem, except this time I know b instead of a, but I know what c equals, I know what b equals, I want to know what a equals. And again, it's a vertically positioned ellipse, which tells me that here, c squared is equal to b squared minus a squared. If I put c, which is 4 squared here, equals b, which is 6 squared minus a squared, 16 equals 36 minus a squared. Move the a squared left, make it positive, 16 right to make it negative, so a squared is equal to 20. And again, I just make this little list of criteria, things I need to know. What do I need to know to get the answer? I need these 4 things, either a or b or a squared or b squared, doesn't matter. Whichever one you get, make sure you write it that way though. So this is a squared equals 20. So if I go back here, x minus 0 squared over a squared plus y minus 0 squared over b squared is equal to 1. Again, this is a squared, so it's already been squared, so just write 20. This isn't squared, so 6 times 6 is 36. Make sure that a lot of times you get 1 squared, 1 not squared. That kind of stuff happens pretty often. So just identify them properly here and put them in correctly over there. And if you get the minus zeros, don't feel like you have to write x minus 0 squared. That's fine to write x squared and y squared. All right?